Welcome to True Projects. In this video, we are going to explain about project titled Covid19 Detection from Chest X-ray using CNN. The project is to utilize the convolution neural network in order to identify the COVID-19 cases from chest X-ray images. The significance of accurate and efficient diagnostic tools has become more apparent during the COVID-19 pandemic. The research aims to address this need by harnessing the capabilities of deep learning and image analysis to create a strong automated system for detecting the COVID-19. By utilizing a dataset of chest X-ray images and implementing the CNN algorithm, the project aims to classify the images as either positive or negative for COVID-19, ultimately enhancing the diagnostic capabilities in the battle against the pandemic. The main goal of this project is to create a precise and dependable system that can identify the COVID-19 cases by analyzing the chest X-ray images through the application of convolution neural network. The project encompasses the severe specific objectives, which include the preparing the dataset by standardizing and adjusting the image sizes, conducting training and evaluation procedures using various algorithms like custom CNN, VGG16, SVM, random forest, and many on the dataset, comparing their effectiveness using the evaluation metrics and convolution metrics, and ultimately developing a system which is capable of accurately predicting the COVID-19 presence from test images. These are the basic requirements that are needed to build this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDEL with version of 3.7. These are the modules that are implemented to build this project. Upload COVID-19 chest X-ray dataset. This module allows the users to upload the dataset consisting of chest X-ray images related to COVID-19. These images will serve as basis for training and testing the detection system. And the second one is pre-process the dataset. In this module, the images from the dataset are processed. The module reads the pixel values of each image and perform the normalization and resizing the operation to ensure that the images are in format acceptable for input to the CNN model. In this project, the images are resized to the dimension of 64 x 64 pixel. And the third module is Run Custom CNN Algorithm. This module involves the implementation and execution of the custom CNN algorithm. The pre-processed image are fed as input to the CNN model, which then apply various CNN layers to extract important features from the dataset. The model is then trained using the extracted features. Once trained, this model can be used to predict whether the test image contains the signs of COVID-19. The fourth module is Run VGG16 algorithm. This module focuses on training a VGG16 CNN model. The VGG16 architecture is a pre-trained CNN model known for its effectiveness in image classification tasks. The module involves training the VGG16 model using the pre-processed dataset. Additionally, it calculates the various evaluation metrics such as precision, recall, F1 score, and accuracy, along with a confusion matrix to access the performance of the model. And the fifth module is Run SVM algorithm. This module involves training a support vector mission model. SVM is a machine learning algorithm that can be used for classification tasks. Similar to the VGG16 module, this module trains the SVM model using the pre-processed dataset and calculates the evaluation metrics such as precision, recall, F1 score, accuracy, and confusion matrix. And the sixth module is Run Random Forest Algorithm. In this module, a random forest model is trained. Random forest is an ensemble learning algorithm that combines the multiple decision trees to make the prediction. The module trains the random forest model using the pre-processed dataset and calculates the evaluation metric such as precision, recall, F1 score, accuracy, and confusion matrix. And the seventh module is Run ResNet algorithm. In this ResNet algorithm, the pre-processing the resizing the images, normalizing the pixel values, and training the set optimized model parameter with an optimizer and loss function. Evaluate the trained ResNet model on the testing set, measuring the metrics like accuracy, precision, recall, and F1 score. And the eighth module is Run EKNN algorithm. In EKNN algorithm, it extracts relevant features from the chest X-ray images and create an ensemble of KNN classifier by training the multiple KNN model with the different values of K on the extracted features. Use this ensemble to predict the class of test image either through the majority voting or considering the confidence scores of each classifier. And the ninth module is Detect the Covid-19 from the test image. This module allows the users to upload a test image which will be processed by the trained CNN model. The model predicts whether the image shows signs of COVID-19 infection or not. And the final module is Accuracy Comparison Graph. This module visualizes the comparison of accuracy and loss between the custom CNN and the VGG16 model. The graph provides a visual representation of the performance of these algorithms in detecting the COVID-19 from the chest X-ray images. The execution of this project. To execute the project, first we need to open the code folder. This is the folder consisting of different files. This is the folder named COVID chest X-ray dataset consisting of two different folders, that is COVID and non-COVID. Here it consisting of different X-ray images. In the same way, for non-COVID 2 it consisting of different X-ray images. And this folder will have the .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making predictions on new data or performing the specific operations. And the folder test consisting of four types of folders: anemia, COVID, non-COVID and opacity, which consisting of different X-ray images. And the folder test images consisting of different X-ray images which is used for testing the model. And COVID-19 detection, test 1, test train, VGG are the different code files, and the run is an bat file. This is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on the run.bat file for the execution. This is the graphical user interface. With this, we are interacting with the program. And click on Upload COVID-19 Chest X-ray dataset. Using this, we are going to import the dataset from the corresponding folder. And select the COVID Chest X-ray dataset and select folder. Here we get a screen like this of dataset is loaded. And now click on Pre-process Data button to read and process all images. In this screen, all images are processed and testing. I am displaying only one image to check whether the image is loaded properly or not. And now close this image. Here in this screen, we can see the total images found in the dataset is of 716. And the dataset is ready. And click on Run Custom CNN Algorithm button. Here, by clicking on the Run Custom CNN Algorithm, the model is trained with the updated dataset, and this is the confusion matrix of the custom CNN model. Here, the x-axis represents the predicted class and the y-axis represents the true class. Here, this box represents the true negative, yellow box represents the false positive, and the blue box represents the false negative, and the violet box represents of true positive. And then close this graph. Here, The CNN used the accuracy of 97, precision of 97, recall of 99 and F-score of 98. And click on Run VGG16 algorithm button. Here, the VGG16 algorithm model is generated and it gives the confusion matrix of x-axis represents the predicted class, y-axis represents the true class. Here it is true negative, false positive, false negative and true positive. And then close this matrix. Here, the VGG16 gives the accuracy of 78, precision of 37, recall of 50 and F-score of 42. And click on Run SVM algorithm button. Here, the SVM algorithm model is generated and it uses an confusion matrix where the x-axis represents the predicted class and the y-axis represents the true class. Here this box represents the true negative, false positive, false negative and true positive. And then close this matrix. And click on Run Random Forest Algorithm button. Here, the random forest algorithm model is generated. Here, x-axis represents the predicted class, y-axis represents the true class. This box represents true negative, false positive, false negative, and true positive. And close this matrix. And click on Run ResNet Algorithm button. Here, ResNet algorithm model is generated where x-axis represents the predicted class, y-axis represents the true class. Here, this box represents of the true negative, false positive, false negative and true positive. And then close this confusion matrix. And click on Run EKNN algorithm button. Here, the EKNN confusion matrix as of x-axis represents the predicted class, y-axis represents of true class, true negative, false positive, false negative and true positive. And then close this. Here, the EKNN gives an accuracy of 97, precision of 95, recall of 97, F-score of 96. And click on Detect the COVID-19 from test image. Here, it use the test images folder. Here we can select any one of these images and I am selecting the 101 image. And here it gives of identified as damage due to anemia. In this way, COVID-19 detection will be done by using the chest x-rays using CNN. And click on Accuracy Comparison Graph. In this graph, x-axis represents the epochs and y-axis represents the loss values. In this graph, green line represents the custom CNN accuracy and yellow line represents the VGG accuracy and blue line represents the VGG loss and red line represents the CNN loss. In both algorithms, we can see the CNN accuracy is more compared to the of VGG and CNN loss also reduces to 0. And then close this graph. In conclusion, this project demonstrates the effectiveness of convolution neural network for COVID-19 detection from chest X-ray images. The result indicate that custom CNN algorithm outperform other algorithms such as VGG16, SPM and random forest in terms of accuracy, precision, recall and F-score. The developer system provides a reliable and efficient tool for automated COVID-19 diagnosis, aiding in early detection and timely treatment of infected individuals.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.